Welcome to the first lesson on Java threading, which gives an introduction to the concept of threads, as well as Java's realization of this concept in the form of thread objects. In this part of the lesson, we'll first explain what concurrency is, which involves the execution of multiple instruction sequences simultaneously, which sometimes means literally at the same time, for example, on multiple processor cores, and sometimes means logically simultaneous, in other words, time sliced over a smaller number of processor cores. Applications can use multiple Java thread objects to concurrently run computations that may or may not interact with each other. So what's a Java thread? A Java thread is an object that contains many useful methods, and we'll be discussing quite a few of these methods in upcoming lessons. Thread objects are the most basic way of obtaining concurrency in Java. A Java thread object is essentially a unit of computation that runs in the context of something known as a process. This gray round angle represents a process, which is the unit of resource allocation and protection in Java. The types of resources that can be allocated in the context of a process include things like virtual memory, file and socket handles, synchronizers, and so on. And the types of protection mechanisms that are provided include things like memory isolation via memory management units. This squiggly line with an arrow is a way to represent the Java thread object, which executes a stream of instructions within a process. A Java thread object can run on one or more processor cores throughout its lifetime, based on one or more schedulers, which can exist at the operating system kernel level, as well as within the Java execution environment, or Java virtual machine level. A Java thread object can also run on different processor cores throughout its lifetime. For example, a thread might start out running on one processor core, be suspended and resumed on a different processor core at other points in its lifetime, be suspended and resumed on yet a different processor core, and so on until it completes its task. Multiple thread objects can run in multiple processes atop multiple cores on a computer. For example, here we see process A, which has 3 thread objects, process B, which just has 1, and process C, which has 2. Note the focus here is on threads running within a given computer. We can start thinking about broader ranges of computation involving multiple processes and multiple threads across multiple computers, but that gets us into a different topic area, which would be served by other courses on topics like scalable microservices. Let's now discuss different ways that Java thread objects can interact with each other. Java thread objects can interact in various ways. One way is for thread objects running within the same process to communicate with each other by message passing, which involves passing objects back and forth between threads in the process. Likewise, Java thread objects running within the same process can also interact with each other via shared objects, also known as synchronizers, which help to coordinate or ensure that multiple threads don't access the same memory regions at the same time. This course doesn't go into great detail on Java message passing and shared object synchronizers. These topics are covered more extensively in other courses, such as the one that's linked at the bottom of the slide. Java thread objects running in different processes can interact in various ways as well. For instance, Java thread objects can interact using shared memory, which is a feature provided by the Android operating system platform. Likewise, Java thread objects running in different processes can also interact using different types of inter-process communication or IPC mechanisms, such as sockets or Android's binder mechanisms. We don't focus on shared memory or inter-process communication at all in this course, but if you're interested in learning more about these topics, particularly how to communicate by message passing, please take a look at this link at the bottom of the slide, where we talk about different ways to communicate using scalable microservices in Java. We're now going to discuss 2 different types of thread variants in very modern Java, which is my name for Java 19 and beyond. Very modern Java supports 2 different types of thread objects. For many years, Java thread objects have been associated one-to-one with operating system kernel threads. In particular, the operating system allocates significant resources for each Java thread, such as a 1 megabyte runtime stack that resides in the operating system kernel. In very modern Java, this type of heavyweight Java thread object is now called a platform thread. A Java platform thread is associated with a kernel thread and has various unique data items, such as an ID, which is a number, a name, which is a string, its runtime stack, its priority, the current state of the thread, is it running, is it blocked, is it in some timed wait state, and so on. Thread local storage, instruction pointer, stack frame registers, etc., etc. Very modern Java also defines virtual threads, which are lightweight concurrency objects multiplexed atop one or more platform threads, also known as carrier threads in very modern Java lingo. A Java virtual thread is multiplexed atop of these platform threads, and it also has some unique data. For example, its ID, its name, its priority, its current state, something called scoped values, which are a lighter weight replacement for thread-specific storage. But you'll notice it doesn't have its own kernel-level runtime stack that's shared by the pool of platform threads that the virtual threads are multiplexed atop. We'll talk much more about virtual threads and platform threads later in upcoming lessons, but be aware that virtual threads and platform threads can coexist in the same process in very modern Java. Some concurrent programs are embarrassingly parallel. In other words, their threads have no dependencies on each other, and there's no need for them to communicate to share results between them. However, other concurrent programs share Java static and dynamic objects across either type of Java thread object, virtual thread, platform thread, and so on, within a process. Be aware that anytime you start sharing data or Java objects, you need to understand Java synchronizers in order to share these resources correctly and efficiently. Let's wrap up this lesson. Here are some of the key points that I'd like you to remember as a result of watching this material. First, there are now two different types of thread objects in very modern Java. Virtual threads, which are lighter weight, and platform threads, which are the traditional Java threads, recast in a way that maintains their behavior and are used as the basis for running the virtual threads. Java thread objects have some unique data and some shared data. Each Java thread object has its own unique data. For example, its name, its identifier, its current state, and so on. Platform threads also have a runtime stack in the kernel and thread local storage, and so on. And thread objects can also share certain data, such as static and dynamic data objects within a process. Keep in mind, however, that sharing data between Java thread objects is tricky. It is actually a bit beyond the scope of this particular course. If you want to learn more about why it's hard to share objects, take a look at the link at the bottom of the slide, which talks about why shared mutable state or shared mutable data is the root of all evil in concurrent programs. These challenges motivate the need for Java synchronizers, as well as Java concurrency and parallelism frameworks that go above and beyond what the basic thread mechanisms provide. And you can find more information about these topics at the links at the bottom of the slide. Finally, it's important to recognize that concurrency and parallelism are similar, but not identical concepts. As shown in this interview with Ron Pressler, who's one of the chief concurrency and parallelism architects for Java, parallelism is about cooperating on a single thing, whereas concurrency is about different things competing for resources. And naturally, through other courses, we'll be covering all these topics in much greater detail. So that's the end of the introduction to threads and Java thread objects.